All right, today for Algebra 2, we're doing 3.2, day 2, and we're doing elimination. We're going to conquer elimination today. So our objective is to solve systems of linear equations by elimination. And to do this, solving by elimination, we're going to add or subtract the equations to eliminate a variable. Okay, so a couple different things we can do. If the coefficients of a variable are additive inverses, we're going to add the equations. If the coefficients of a variable are the same, okay, so if they're additive inverses, we're going to add. If they're the same, we're going to subtract. And if coefficients of the variable are not the same, this is the one where it gets a little tricky. We're going to multiply one or both equations by a constant to produce equations with opposite coefficients for one variable, only for one variable. Again, probably doesn't make any sense to start with, but I'm going to make it make sense. Because remember, solving a system of linear equations by graphing is not always an option. So you can solve them algebraically using one of two methods. We did substitution yesterday, so we're doing elimination today. All right, so let me clear this and move it up. All right, so let's look here. To solve this system in example 3, we have x plus y equals -1 and 2x plus y equals 2. So notice, okay, that these two both have a positive y. Okay, they are the same. So if the coefficients of a variable are the same, we can subtract the equations from each other. Okay, that's what we're going to do, is we're going to subtract them. So I'm going to take, and it doesn't matter which one you do, quite honestly. So we can take x plus, pardon me, oh my goodness, I can't write. X plus y equals -1, and we're going to subtract 2x plus y equals 2. Now, this can get a little confusing for people, okay, to do the subtraction. So if you would rather distribute this negative sign and have x plus y equals -1, and so this is going to be -2x, negative times a y is -y, equals a negative times 2 is -2. That is also okay. That just changed these to be y, positive y and negative y, change them to be additive inverses. And so you're adding, you're combining like terms. So it doesn't matter how you do it. Okay, it's perfectly fine, but like we ended up having this additive inverse, which is what we want. Okay, so let's go through this first way. So x minus 2x, we're doing the math down, okay, and across. So x minus 2x is -x. Y minus y is 0. There's nothing there, right? Those cancel. So you can cross them out, you can put 0, doesn't matter. -1 minus 2 gives me -3. So I'm left with -x equals -3. I'm going to divide by -1, and I get x equals a positive 3. Okay. That's the same thing that happens here. I just distributed the negative sign, so x minus 2x is -x. Y minus y is nothing. -1 minus 2 is -3. Divide by -1, x equals a positive 3. It doesn't matter if you distribute the negative or not. You just don't want to forget it's there when you're subtracting, is the big thing. Okay, but what we did was we eliminated, notice, it's called elimination because we eliminated a variable. We eliminated the y's intentionally so we could solve for the x. Now that we have the x, we're going to plug it into one of the equations. I'm going to pick the easiest one. So I'm going to pick this x plus y equals -1. And I'm going to plug my x of equals 3 into my equation. So I'm going to say 3 plus y equals -1. So I'm going to subtract 3 from both sides. Y equals -1 minus 3 is, good, -4. So what is my solution? What is my solution? Good. It is 3, negative 4. It's that ordered pair 3, negative 4. Again, I have 1 point. That's my solution. So what type of system do I have? Perfect. Independent, consistent. Okay, so we are eliminating a variable. Doesn't matter how we do it. Like which variable we eliminate, we're just having to eliminate 1. Okay, how do we get them to cancel out? Okay, let's go on down here to example 4. Solve the system. It's a little crooked there, I guess. I could straighten it up. Okay, example 4 to solve the system. We have 2x plus 6y equals negative 4. 5x plus 2y equals 1. So none of these are the same or additive inverses. So we have to multiply by a number that's going to make one of the variables the same. These are the y's are the smaller ones, so that's what I'm going to do. Okay, I'm actually going to multiply them by a number to make them opposites. Okay, so I want to get the opposite of a positive 6. So what do I need to do to 2, a positive 2, to get a negative 6? Because I want the opposite. What would I multiply by? 2 times what would give me a negative 6? Perfect, negative 3 is what I want. So negative 3 times 5 is going to be negative 15x. Negative 3, so I'm distributing. Negative 3 times 2y is going to be negative 6y. And negative 3 times 1 is going to be negative 3. Okay, I didn't do anything to my original the top equation. It stays 7x plus 6y equals negative 4. But notice, okay, I now have a positive 6y and a negative 6y. So they equal 0. I have eliminated my y variable. It's gone. Now I can do the rest. 7x minus 15x. So 7 minus 15 is going to give me a negative 8x equals negative 4 minus 3 is negative 7. Okay, this is one of those reasons, elimination is one of those reasons that I talk about, like it's so important to balance your work and things and to know how to do that so you don't get lost. All right, so we have to get x by itself, so we need to divide by negative 8. X equals negative 7 divided by negative 8 is a positive 7/8. Okay, now that I have my x value, what do I do? Good, I substitute it in to one of the equations. Doesn't matter in the least. So let's take the 5x plus 2y. 5x plus 2y equals 1. All right, I'm going to plug my x value into that equation. So I'm going to have 5. X is 7/8, so times 7/8 plus 2y equals 1. You know what? Well, I guess it wouldn't matter if I chose the other one. Neither one of them would have been real pretty. Okay, so 5 times 7 is 35. 8 plus 2y equals 1. We're going to subtract 35/8. So that'll give us 2y equals, all right, 1 is equivalent to 8/8, right? So 8/8 minus 35/8. Anybody got that? Good. Is negative 27/8. All right, typically we would divide by 2, but I have a fraction over here. Do you really want to take a fraction, negative 27/8, and divide by 8? Or divide by 2? Probably not. So we can, the other option is to multiply by the reciprocal, right? So we can multiply both sides by 1/2 instead of dividing by 2. So then our 1/2 times 2 is just 1. So we have y equals negative 27 times 1 is negative 27. 8 times 2 is 16. So y is negative 27/16. Yikes, ugly numbers. Could you imagine if you were trying to graph this? Like, just think about that for a little bit. Like, what would that actually look like? You would not get these fractions. You wouldn't be able to figure out the point of intersection. All right, so our solution here is what ordered pair? What's a comma? Good, it is 7/8, comma, negative 27/16. Perfect. So what type of system is this if it has a 1 point for its solution? Excellent. It is independent, consistent. Independent, consistent. All right, let me see about the back. Okay, we do have problems on the back. I couldn't remember for sure. Should have checked it. All right, so then I have another example on the back to solve the system. Okay, so example 3, this is one of those systems, okay, like we have y by itself. You could use substitution on. That's when I told you was the ideal time to use substitution. But you don't have to use substitution if you don't want to. And so there's nothing wrong with doing elimination, okay? You have all the tools, you just get to pick what you want to do. All right, but again, we have 3x and 6x. They're not the same or opposite of each other, additive inverses. Y and 2y, not the same, okay? So we need to multiply by a number to get them to be opposite. Okay, so let's take this top one. I have 3x. Let's get the opposite of 6x. So we want a negative 6x. So 3 times negative 2 would get us that. Okay, so negative 2 times 3 is negative 6x. Negative 2 times y is negative 2y. Negative 2 times 5 is negative 10. Pardon me. And then we have 6x plus 2y equals 4. All right. So negative 6x and a positive 6x cancel. We've eliminated x. Negative 2y and positive 2y cancel, and we eliminated x. So now we have nothing over here equals negative 10 and a positive 4 would be negative 6. So what's up with that, do you think? What is up with that when we have negative 6, or pardon me, 0 equals negative 6? So do we have a point of intersection? No, definitely not. So what do you think we say here? Like, what is our solution? Yeah, right? There's no solution here. No solution. Okay, so we could say it like this. We could say no solution. Okay, whichever way you want to do it is fine. But if you end up with an equation that's a false statement, you have no solution. So what type of system would this be if we have no solution? Do you remember? Okay, good. It is an inconsistent. I'm dropped my marker, but I caught it. This is an inconsistent system. Okay, no solution is inconsistent. All right, I will see you all tomorrow. Have a great evening.